Good afternoon, everyone. I'm going to talk to you about how Facebook designs AI applications at scale and how they impact the lives of the people we serve. So Facebook's mission is to give people the power to build community and bring the world closer together. People are really at the center of all of the work that we do. If you saw Paritosh's talk earlier this morning, right, he also stressed on really identifying and focusing on people problems. And this is something which is very central to us here at Facebook. Even our product philosophy is that we should be focusing on people problems. These are neatly articulated problems and opportunities for the 2 billion people that we are serving. Applied machine learning is the applied research arm at Facebook. We are tasked with bringing a lot of the state-of-the-art machine learning technologies and solutions into various products across Facebook. We partner very closely with multiple teams. These include the Facebook AI research team, FAIR, several product teams, even our infrastructure team to make sure that our solutions are very scalable. Our charter is to advance the state of the art, build new product technologies and deploy them, and then democratize AI. And I will talk a little bit about the democratization in this particular talk. But to understand how we are building our applications at scale, I would like to walk you through some of our values. We focus on scale, obviously. With the number of people that we are serving, we absolutely need to build scalable solutions. We focus on impact. And this is where we have to make certain hard trade-offs, but we really try to address the hard problems that have a very significant impact in the world. And then it is move fast. The philosophy here being, let's build a good enough solution, let's put it out there, and get feedback from our users. And our users will give us all of the feedback that will help us to iterate and improve on the solution. When I was in graduate school, I felt like a wizard. I had a certain specialization and was able to solve some very interesting machine learning problems. And a lot of these you might relate with. These were point solutions for classification or maybe for anomaly detection. And one problem after the other, we picked the best approach, tried to solve them. As I came to the industry and as I progressed through my career, I realized that this approach doesn't scale. Wizards don't scale. And the number of problems that we were dealing with were numerous. Not only that, the domains that we had to work with were very new, very different. These days, we are dealing with video data, with audio and speech data, with text, with social connections, and so on. These things did not exist or were not as prominent when I was a graduate student. Even at Facebook, we've come to the realization that it is extremely important to try and build platforms that will help to democratize the AI solutions. So what we have done is to build this platform, which we call FB Learner, that encompasses a lot of the machine learning technologies. The key principles behind this are, number one, scalability, of course, but more importantly, reusability. We have a lot of people at Facebook who are developing the workflows, and these workflows can then be repackaged and reused for multiple applications. It also abstracts out a lot of the nitty-gritty details of machine learning so that we can have engineers who might not necessarily be trained in computer vision or in speech still be able to build machine learned models and solve very interesting problems. So this, sorry, hit it too fast. Nearly 70% of the users of the platform are non-AI experts. Over 25% of the engineers are active users of this particular platform. We've also built a strong applied research community. For every 10 users of the workflow, there is actually just one developer. So there are a few developers who are developing the workflows, but these are used across many different applications. And obviously, we are enabling AI at scale because the platform is a single place where we can collect a lot of the training data and then have a repository of a lot of the models. On top of this platform, we're now thinking about the right engines that we need to build. A lot of you out here, I'm sure, are using Facebook. You've probably interacted with different posts that have photos and videos in them. Content understanding is a very big area for us. And content these days is in the form of pictures, videos, sound, etc. And of course, the text that people use as they interact with their friends and the people they care about. I'm now going to talk to you about 4 different content understanding engines and how they fit on this FB Learner platform and the type of problems that we are able to solve with this. At Facebook, data drives all of our product decisions. And this is extremely important because what we do is analyze the data, identify the insights, to find out what are our biggest opportunities. Remember the focus on impact piece, right? And once we have the biggest opportunities, then we can optimize on those. Here is a very quick example of Instagram. So I'm sure several of you are familiar with Instagram. This is one of the apps within the Facebook family. For the longest time since its inception, Instagram was ranking its news feed in reverse chronological order. Right? The newest post would appear right at the top. As the ecosystem grew, we started getting a lot more people posting and a lot more users consuming. Our analysis showed that a lot of the users were missing a large portion of the posts from the friends they actually cared about. In fact, sometimes as high as 70% of the posts from your friends were being missed. And people started internalizing this and saying, oh, well, maybe this is not necessarily a platform for me as a regular user, but it is a lot more about celebrities and large pages. Once we realized this, we decided to pivot to a rank-ordered feed, where we can personalize the feed based on your particular needs and experiences, and really help to show you the content from the people that you care about. So in this particular example, now in my Instagram feed, I can actually see posts from one of my high school classmates, who is a coffee connoisseur, to one of my former colleagues, who's now the CTO at Cloudera, to a current colleague who has just visited France. So these are people in my circle, people who I care about the most. Analytics helped us to identify the opportunity, and machine learning, the FB Learner platform that I talked to you about, was the key to the solution. Now to the content understanding engines. The first one I want to talk to you about is computer vision. The computer vision platform allows people at Facebook to build and deploy new computer vision models on the fly. Okay. It enables you to collect the training data, train your new models, deploy them in production, and then refine them based on the analysis that you are doing on the models that are deployed. And again, remember, we are trying to enable a lot of people who are not necessarily computer vision experts by providing these kinds of toolboxes and technologies for them. The types of applications this enables is huge. Smriti already talked about a couple, right? We are able to describe the photographs to visually challenged, resurface some old memories. Sometimes you might see photographs that you've posted 2 years, 5 years ago that are resurfaced, right? Provide better image and video search functionality, and protect people from objectionable content. We have more than 200 visual models that are trained and deployed, and dozens of teams across Facebook are able to avail of this functionality. One of the things that we have noticed while building these machine learning models is that the underlying training data, right, is constantly changing, right? And so we would capture a lot of the training data, build the models from them, but then As time goes on, right, new concepts emerge, and newer data gets posted onto Facebook. Retraining these monolithic models was computationally very expensive. So we had a situation where these things were taking, days, sometimes even months to train. Architecturally, this was becoming almost impossible for us to manage. This resulted in a pivot and a re-architecting of the computer vision platform to actually have multiple layers. What this does is we are able to expose the different layers of the network to the various teams. The teams can then choose to plug in at different points. Certain teams might actually just plug in right at the top of the network, in which case they get very coarse-grained features. They are able to build and deploy their models very quickly, but we might suffer in terms of the accuracy. Other teams might actually want very fine-grained features to be provided to them, in which case they will plug in at the very bottom of this modular network. Right? And so essentially, the type of trade-off that we are able to offer is something that you can consciously choose and say, okay, for now, I quickly need to deploy an application to see how well it does. Well, let's go for low compute. I'll sacrifice a little bit on the accuracy. Based on the user feedback, then I will invest more in computation in the model building and then gradually go up the compute accuracy curve. Let's see one example from the computer vision platform. It processes so many different images in any single day, right? This is an image of a friend and close colleague's daughter. She's riding a horse. We fed it to the computer vision platform, and it came up with certain concepts, right? And so horse, it gives the concept as well as the confidence score. Animal, people riding a horse, sky, ranch. I don't know so much about cloud. I think we can do a better job there. But you get the point. We can take any arbitrary image, and it tries to tag it with various concepts. Text understanding is another huge challenge for us. As people, we are very tuned to speaking with each other in slang, sometimes using sarcasm, but people can easily interpret that. Trying to get the machines to do this, you can imagine, is a huge challenge. Our deep text platform helps us with several different applications. Language translation is a very big application. We have thousands of posts per second that are coming in. 4 billion posts or more are translated on any single day, and we are supporting 45 or more languages currently on our platform. We are constantly evolving the underlying models. Just recently, we have deployed the new convolutional neural network model that essentially helps us to process the text in chunks as opposed to individual words and phrases. What this has done is not only helped us to increase the accuracy, but also reduce the amount of training time. Despite these advances, trying to translate every post in every language can be computationally very challenging. Our solution was to do lazy translation. So essentially, this is a page that I follow. It's the Mysterious World page, predominantly publishes in the Spanish language. This is a language that I don't understand very well. Right? Our language models determine that the language of the viewer is different from the language of the post, and it provides a C translation link. As a user, I can click on that link and see the translation. Our analysis showed us that introducing this additional level of friction actually caused a lot of people to just skip over these posts. These are important posts that they care about, but especially on your mobile device, right? Looking at this small link, trying to click on it to see the translation was very difficult. On the other hand, our technological challenge was, well, pre-translating all of the posts in all of these languages can be computationally very hard. Analysis, again, helped to drive the strategy here and said that, well, actually, if we focus on some of the large pages and the celebrities, these are the people that have the widest reach, okay? And pre-translate their posts, we might be able to improve the user experience dramatically. So what you will see now is an approach where if I see this particular post in my feed, I will actually see it translated in English, correct? Of course, I have the option of going to the original translation, and if I click on See Original, it'll show me the original text, okay? Language has many different applications. These days, we want to do conversation understanding, especially as we think about our messenger platform when users are communicating with each other, and explore the opportunities of getting third-party services to plug in. What we want to do is to try and understand what is the context of the conversation. So here is an example of looking for a ride. Of course, this is a toy example, but the point here is we want to correctly determine when the user is interested in getting a ride, and then see if we can trigger a suggestion for a third party to plug in, correct? But we also want to make sure that we don't trigger these suggestions in frivolous cases. So let me play this for you. I'm typing in, hey, I need a ride, you get the suggestion. I don't need a ride, you don't get any suggestion, right? Let's take a ride, again, the suggestion is triggered. I like to ride donkeys, clearly this is frivolous, no suggestion, correct? And so on. Now this is very difficult in the English language. Imagine having to do this in so many different languages and correctly identify the context of the conversation. The next application is trying to determine if a post is a sales-oriented post, correct? We saw that a lot of the users were actually posting, for sale items. There are actually for sale groups that are available to us, and there is the marketplace functionality that is available to us. So instead of just posting into your friend circle, we want to guide people to post in the appropriate pages. Now that said, it is important for us, again, to recognize the context, right? That, are you trying to sell something? If so, if you can create a sales post, it will help you to sell your item faster. Again, take a people problem and see if we can solve it in the right way. Behind the scenes, there is a lot of applied machine learning that's going on. Okay. Next application, similarly, recommendations. We have a lot of users on the platform who seek recommendations from their friends. It is important for us to detect the right context and also figure out whether the recommendation needs to be global or local. In this case, the person is having a bad hair day, looking for a recommendation in a New York City salon. Well, we want their friends to post recommendations, but these definitely have to be local salons within New York City, right? And so not only are we trying to identify the context, but then digging deeper to say, hey, is this a local recommendation or a global recommendation, and what are the right types of recommendations that can be surfaced out here? Speech and video is becoming extremely big, as you can imagine, right? By the time this talk ends, millions of minutes of video would have been uploaded to the Facebook platform. Okay. In terms of image processing, we're doing fairly well, taking static images, right? Individual images, this is of my colleagues, we are able to identify people, some posters, some signs, and even plants, and these are just color-coded for ease of understanding. Our point now is to try and scale this up to videos. So you see that we have recognized the pose. There is a person that is walking by in the video from left to right, and we are able to identify that person very quickly. So far, so good. Our goal is to get to a full understanding of videos. Here is a teaser. So we have some friends sitting out here. Another friend comes in, asks them to go for coffee. We're trying to identify the people. We're trying to track the motion. We're trying to detect the speech, right? They have asked for coffee, and doing translation. Now, obviously, we are much, much farther from there, but you can imagine the challenges that we face. A lot of the video that is uploaded onto the Facebook platform is user-generated content, which means it does not have a whole lot of metadata, right? And in order to do proper understanding, we have to analyze these multimodal signals and try and make sense of them. Okay. The next application focuses on the AI-powered camera. As you've all noticed, the camera has become a powerful input device that is allowing us individuals to unleash our creativity. Right? Not only can we take pictures and videos and share them, but there is a lot of processing that can be done on these photos and videos. However, in order for us to do this at scale and in real time, we have some important challenges. The models that we have built need to process the images and videos on the device, which means these models have to be scaled down by almost 100x. Right? It's great to have them in the data centers on very high-end development servers. That's perfectly fine for back-end applications. But with the camera applications, we are increasingly seeing the need to do the processing on the device. Not only should the model size be small, but we cannot sacrifice on the quality of the models or in terms of the response time. Correct? What we have done is actually partnered with several companies and come up with an open source framework, cafe2.ai. This is open source that allows you to bring AI to your mobile phones. And this is a lot of hard work from people within Facebook and also our partners, including Microsoft, Amazon, Intel, Qualcomm, and others. The idea is to have the technology available so that you can build these interesting effects. So here is an example, right? You can see masks, you can see augmented reality type of applications, you can see shaders, you can see style transfer of art, etc. And this is just the beginning, right? We are able to do this for a lot of the cameras that we have at Facebook, right? I mean, obviously, the main Facebook camera, the Instagram camera, as well as the Messenger camera. Right? Now, some of the challenges that we face here are trying to do a lot of things in real time. Here is an example. If we had these still images, we are trying to do depth perception and give a 3D image or a 3D representation of these images. Doing this offline or in the servers makes sense, right? We have the computational horsepower, correct? Now imagine having to do this in real time on devices. Here is an example of a person who's trying to take a photograph. This is one of our colleagues trying to take a photograph. We want to do background segmentation, so we have to identify the depth, and we are blurring the background. Now, all of this is happening on the device, right? The background is blurred. You have different levels of control. Once this is done, they can take a picture. This is a similar example of somebody using their camera in a selfie mode, again, to capture this, to do the depth assessment, and they are actually moving the background. And you can see that we have kept the foreground still. We're trying to keep the foreground still while fading out the background. So these are all very important and challenging problems that we face. I've given you a whirlwind tour of how we have built some of the AI platforms, how we are democratizing this. For the graduate students and the researchers in the room, I'm sure you've already seen some very interesting problems. Just a quick sample of those: multimodal learning. We really want to figure out how best to integrate text and speech and audio signals and video signals to come up with a comprehensive understanding of the videos that are uploaded. Right? Transfer learning is extremely big. As I mentioned to you previously, we have several tasks that are related or very similar. Can we actually leverage what we have learned from one task and then apply it to multiple different tasks? Multilingual modeling. This is a huge challenge for us, right? Let's say if we have to build a translation model for every language pair that we are interested in, or a translation model for every language in which the conversation is being conducted, right? These things can be prohibitively expensive. Can we have multilingual models that essentially learn certain base concepts and then tweak them based on the language or the language pair that we are interested in? And finally, getting neatly labeled and annotated data, as you can imagine, is a challenge, right? Can we move towards weakly supervised learning or even unsupervised learning? And there is a lot of excellent research out there in the field, right? But these are all important questions, not only on whether or not we can solve these problems, but more importantly, can we do this at scale? I want to leave you with a few thoughts, right? Number one, there are a lot of interesting applications, but at Facebook, we believe that this journey has only begun, right? We are only 1% done. There is a lot more that needs to be done. A few takeaways. My personal belief is that some of the success of the AI applications at Facebook comes from the fact that we focus on people problems, that we are able to leverage data insights to drive the product decisions. So we will not work on a problem just because it is a cool problem, but because it solves an important people problem and it is high impact as identified by data. Building at scale and then trying to democratize AI so that multiple people across the company can leverage their creativity and their skills to build very interesting applications. Now, the work I have presented here is actually work of a large team of people, and I want to acknowledge them. It's a great privilege to be working with them and learning from them. Thank you so much for your time.